electrostatics, magnetostatics, electronics, thermodynamics, atoms and nuclear, wave optics. Okay, in this first section, I am going to discuss classical mechanics with you. As a first question, we can move to for a particle executing simple harmonic motion at its mean position. Okay. There is four options there. Velocity is 0 and acceleration is maximum, and velocity is maximum and acceleration is 0. Both velocity and acceleration are maximum, both velocity and acceleration are 0. So we want to know about the properties on the velocity and the acceleration. Okay, I will draw an example for a simple harmonic motion as a pendulum. Okay, you are familiar with the pendulum. This is the main position and this is the farthest position. So amplitude is measured from the main position. These two positions are the amplitude and they are the farthest position. Okay. When a bob is oscillating, with respect to this main position, this bob will have maximum velocity at this position. Okay, we know that in this position the velocity will be maximum. But this bob come to rest and retrace its path towards its main position when it reaches its amplitude. Okay, so we can conclude that the velocity is maximum at its main position. This is a practical example. By theoretical, we know that velocity is equal to omega root a square minus y square. What is omega? It's angular frequency, and a square, a is the amplitude, the distance from the mean position to the extreme points. Okay, and y is the displacement from the mean position. Okay, at the mean position y is 0, so v is equal to omega a. That means maximum. So velocity is maximum in the mean position. But when we are come to the acceleration, the equation for acceleration is minus omega square y. Okay, minus omega square y. At the mean position, we know that y is 0. So acceleration is 0 at the mean position and velocity is maximum at the mean position. So which option is correct? Option B, velocity is maximum and acceleration is 0. Option B is the correct answer. Okay, we can move to the second question. A motorcyclist moving towards a huge cliff. Okay, consider that here is a cliff is there and a cyclist is moving towards the cliff and with a speed of 80 km per hour. Okay, we can write as the velocity as 18 km per hour. Okay, blows a horn of source frequency 325 Hz. So we can write F as 325 Hz. Okay. If the speed of the sound in air is 330 meter per second, the speed is given as 330 meter per second. See, the difference is the unit of this velocity of the cyclist is in kilometer per hour and the speed of the sound is 330 meter per second. That means one unit in kilometer per hour and the other unit is meter per second. So we want to convert the unit of this velocity as 18 into 1 kilometer is 1000 meters. 18 into 1000 divided by 1 hour. 1 hour is 3600 seconds. Okay, we can cut these zeros and 180 divided by 36 is 5. So velocity is 5 meters per second. Okay, frequency is given 325 Hz and the speed of the sound is 330 meter per second. Okay, and the question is, if the speed of the sound is given and the question is the number of beats heard by him. Okay, the cyclist is coming towards the cliff and the question is the number of beats, and the equation is directly given. The number of beats delta f is dependent upon the frequency is multiplied to the Vs, speed of the source, divided by changing the speed. Okay. So, speed of the 5 meter per second and the speed of the sound is 330 meters. So the frequency 325 is multiplied by Vs is 5 divided by the 330 minus 5. It will give the delta F is equal to 325 into 5 divided by 325. See, the calculation is very simple.